My name is Richard France. I have been working with Alstom for about 10 years now. Originally, I started in London on the Jubilee line as an engineer. I started off working on bogie systems, brake systems, doors and stuff like that. And then after about 4 years, an opportunity came up in Dublin to work as the engineering manager. So then I was doing that for the past 6 years, and Aidan, who's sitting over there, actually, he was my predecessor in that role. So I was the engineering manager for about 6 years, covering both the trams and the infrastructure. And then very recently, I've taken the role as project manager in Dublin. So in this presentation tonight, I would like to talk very generally about the Alstom Citadis trams. These are the trams that we have here in Dublin. Then I'll give you a short overview of the trams and some of the systems, because I think that will help with the next section of the presentation, which talks about what we do in terms of maintenance on the Luas. And then finally, I'll open it up to any questions that you have. So the Citadis trams. So in Alstom's portfolio, they have quite a number of light rail vehicles. What you see up here is the current ones that are open to the market. It's not a full picture of every light rail vehicle they've ever produced. For example, in Dublin, the original trams that were made are the XL1 variant, and those they're all used on the Red Line at the moment. More recently, after a number of years, the new trams were purchased for the Green Line, and they are the XO2 variant. Typically now, whenever Alstom sells new products to new cities that are developing the tram network for the first time, they'll have their XO2 trams, which will be there. So if you look to places like Sydney, Australia, you'll see they're taking now the XO5, Dubai as well. Okay, so then Alstom has a couple of bespoke trams for North America and the CIS market, where the gauge is not necessarily the same and the electrification is different. Alstom also offers a dual-list product, which is sort of a cross between a tram and a train. It allows transportation on regional networks and also urban networks, where the overhead line is at a different voltage. Those Citadis trams that I've discussed there are all steel wheel design trams, as you see in Dublin. Alstom also has a range of trams which run on tires, rubber wheels, and they offer you some of the benefits that you'd get with a normal steel wheel network, but you get you get some benefits in terms of better ride comfort. You get better gripping, and because the wheels, the rubber wheels on the rail give you a better braking force. So it's sort of a mix between the two. On the counter, you get a reduction in the energy performance by using rubber tires. So then here, Alstom has sold over 2,400 Citadis trams across 56 cities worldwide. Of those, 1,900 have made it into service. And of modern trams now, which you can distinguish by low floor nature, 25% of them would have been originally manufactured by Alstom Transport. So one key thing then is Alstom offers a catenary-free system. So if you were to go to Dubai and see the trams that they have there, the entire network doesn't run with an overhead line like you have in Dublin. They have an APS system underneath the ground that allows the tram to get its energy. So 97% of the catenary-free mileage run worldwide is run by Citadis. So Alstom is the leader in that area. To date, anyway, the 9 billion passengers have been transported by the Citadis, and every day 4 million passengers are transported. 1 billion kilometers have been run by the Citadis fleet, and 25 million kilometers have been run without the catenary. As I mentioned Dubai before, if you were to go to Nice in France, you would see a section in the center of their city where there is also no catenary there, and those trams they have an enhanced battery on the roof, which allows the tram to get across the short distance that it needs without the catenary. So this slide here shows you the locations where Alstom Citadis are currently up and running. Worldwide. If you look in the top right corner, you see France. So the majority of the vehicles that are actually in operation are in France. It's a French company, and the country has really taken on board the Citadis. In more recent years, though, the market has been opening up in North America, parts of the Middle East, and Australia, and like that. So there you go. So then the general makeup of the trams is, as you might have guessed, it's probably a very basic slide, but you have three different types of cars that make up the Citadis. So you have motor cars, suspended cars, and trailer cars. And you might guess by the name, the motor cars have bogies underneath them that have traction motors that provide torque and power for the vehicle. So the leading car on the trams and the trailing car is a motor bogie, and then typically there's one in the middle of the tram that has a motor bogie as well. In between the motor bogies, there's always a suspended car, and there's different types of suspended car you can have depending on the customer's requirements in terms of what they want for capacity or number of seats and like that. The trailer cars, you have to have a trailer car in every vehicle. It doesn't have motors. It provides a slightly different function in terms of it'll always have a pantograph on its roof and flange lubrication on its bogies. So then these cars can be put together to kind of create any kind of variant of tram that that's needed to meet the capacity requirements of the city. So in Dublin, originally 301 trams were purchased, and there was a project that occurred to increase those 301s to 401s. So just like you've seen here with this slide, a motor car and a suspended car was slotted in to allow that tram to grow. We'll be going through a project over the next in the next couple of years to take the trams that are run on the Green Line and extend them to 50 meters in length. So currently they're roughly 40 meters, and they'll be extended to 50 by the same thing that you've just seen on this slide. So an overview of the trams. So on the roof of the trams you have quite a lot of equipment. There's above the motor cars there's a traction brake control unit which will convert the DC 750 voltage supply that you get off the catenary. It'll convert that into AC power, which will then power the motors and give you torque. What you see on here in green, which is the GRF, that's your motor cooling unit. So the motors that are fitted to the trams in Dublin, they're water cooled. So there's a bespoke unit that has to facilitate a refrigeration cycle on those motors. And then in purple you've got the sort of a rheostat that allows you to burn off excess energy when you're performing regenerative braking. So this slide here shows you the same thing that was on the previous slide, where you have three sections of the traction supply equipment. So this is a breakdown of just one section. So the energy comes in from the pantograph, from the overhead line at 750 volts DC. It passes through a circuit breaker, which then can be used to isolate the trams in the event of an emergency by the driver, or actually if there's a fault on the tram where the tram logic is saying actually we need to perform an isolation because there's something unsafe going on, it'll cut off the power there. But that power goes into the traction module, converted to three-phase and down to the motors. When the driver applies traction with his master controller that's in his cab, you'll get the energy flowing through down to the motors from the overhead line through the traction control unit. When the driver applies braking, though, those motors then perform. They act like generators, and you get the voltage going back up to the overhead line through the inverter as its primary function. But in order for that energy to be recovered, there needs to be another tram in the electrical section to receive it. So primarily it'll go to the line first, but then if there's no tram to receive it, that energy will get dissipated through the braking rheostat. On the underframe of the vehicle, there are motor and trailer bogies, which I mentioned briefly already. The locations, so what you're seeing here is actually a 402 tram that are used on the Green Line. And that's showing you the position of the different motor bogies and the trailer bogies that are fitted to the vehicle. This here is an actual sketch of the two different types of bogies. They're very similar in the sense that they have the same secondary suspension, same connections to the underframe of the carriage. The frame of the bogie is basically the same. You know, the vertical and lateral dampers that help to absorb the energy from the car body is all the same. But motor bogies obviously have traction motors, and they also have a sanding system which helps with the adhesion between the wheels and in the rail. And the trailer bogies, on the other hand, they have a flange lubrication system which helps to reduce wheel wear, which I'll talk about in a bit. Both bogies have friction brakes, so there's magnetic track brakes underneath, and brake calipers, much like you'd have on your car, but those brake calipers are different between the motor and trailer bogies. So this slide here, now this line is showing you a cross-section of one of the transmission bridges that is fitted to the motor bogie. So if I could, I don't know if you can see that there. Yeah, it's a transmission bridge, and then that's one of them. There's two per bogie. So what this does is it transmits the torque from the traction motor through there's a gearbox. It's attached to a gearbox. It transmits the torque from the traction motor to the wheels, and within the gearbox there's two gear steps that help to facilitate this. A transmission axle, which is in the main case, transmits the torque to the other wheel, so that the two are always spinning in sequence, basically. The wheels that are used on all Citadis trams are elastic wheels, rather than, if you were to look at Irish rail trains, they all have monoblock wheels. It's a solid piece of steel. Whereas on the trams, every tram that in Citadis is an elastic wheel design. So the way that works is you have the wheel hub and its mating part, which sandwich together elastic rings, which hold the tire part in suspension and isolation from the wheel, the metal part. So what that helps to do is reduce the vibration from the rail, and it helps a little bit with noise coming from the wheels. On the motor bogies, there's a sanding system. So the sanding system consists of a compressor which charges an air tank and an ejection nozzle. And then when the driver or the tram demands the sand, there's a solenoid which opens up, and the air then helps to suck out the sand and deposits it in front of the wheels. So the sanding system is generally used automatically by the tram. So in the event that there's a slippage between the wheel and the rail, the sanding will be applied and to help prevent that. Because if you get wheel slip, what you can have is little defects that form on the profile of the wheel. So you can get flats, which then need to be machined out, and the life of your wheels can be reduced from that. The driver also has the facility to apply the sanding manually within his cab via push button, but there's typically not really a reason for them to do that. They just have that button there as a feature. We consider that more as a button for maintenance, just to test that the sanding is working. But we actually have found that the drivers will go off and deposit the sand across the infrastructure in various places where they think it might help with the next tram who's going to receive some slippy rails or something. But it's not actually intended as that. The ideal application for sanding is when the tram requests it automatically. On the trailer bogies, trailer bogies, there's a wheel flange lubrication system. So that consists of a tank which holds a biodegradable fluid. I guess it's essentially a vegetable oil or something like that, which is not harmful for the environment. And then a couple of pumps will distribute that oil to some ejector nozzles, which spray on both sides of the wheel flange. And the purpose of that is to reduce wheel wear and also reduce the squealing noise that you get from the wheels running on the rails. There's a file in the tram, in the brain of the tram, that will tell the flange lubrication to start applying on the wheel. So depending, it's usually applied around corners. So if there's a tight corner, then there's a sort of logic file that will say, going around that corner, apply the oil so that there's a minimum amount of wear between the wheels and the rail. Depending on the direction of travel, so the key thing is to reduce wear and to eliminate the squealing noise, but there's an adverse effect of the flange lubrication system, which is that it kind of makes the bogies incredibly dirty, and it also deposits the oil onto the infrastructure, which passengers or the public might think is unsightly and not ideal. So unfortunately, the way the flange lubrication is set up on the Citadis, depending on the direction of travel, you get a good application of the oil. So you can see in the first circle I've got on the picture, when you're traveling, which way is it there? When you're traveling this way, the oil deposits quickly onto the rail, and there's very little splash back up onto the bogie. But when you're traveling in the other direction, the oil gets squirted on the wheel, and it has to travel all the way up and then back down to the rail. So as it's doing that, it flicks the oil onto the underframe of the tram. So when our technicians come along to do the inspections, it's very difficult and not a very good job for them to try to do with all that oil buildup. So the bogies are equipped with friction brakes. There's two types of brakes. So what you see in green are you've got brake calipers and hydraulic units, much like you'd have on a car, to apply braking. But more interestingly, what you have in blue is the electromagnetic brakes. So what happens there is there's a coil in the track brake, which when energized, it turns that into a giant magnet that clings onto the rails, and the braking force coming from that is very high, and the tram will stop very, very quickly. You may have noticed, I don't know whether you're very in tune with the drivers operating the vehicles, but as they approach the stop, sometimes you hear a big clunking sound, and what that is actually is the drivers are pressing a push button in their cab, which activates that track brake, and they do that to just give them that last little bit of braking, but they shouldn't really need to do that. It's just sort of driver behavior, which then that has an impact on the condition of the rail. You can get wheel slippage if they do that. Like that. So the magnetic track brakes are generally they're not applied normally in braking. They're sort of intended for emergency situations. So if the driver was to quickly pull his controller into the emergency braking position, those track brakes would be applied to stop the tram very quickly. Same again. There's an emergency push button in the cab, which the driver can hit, which will energize the track brakes. So earlier we talked about traction and electric braking. Before we talked about the friction brakes. So there's a bit of brake blending that goes on. So what I'm trying to show in green there is that when the driver's moving his controller into the forward position, he's in traction, and that's applying torque to the wheels, and he's accelerating. But when he's in the yellow position, that's your service braking, and so that's, for the most part, service braking is managed by the traction motors, and there's a bit of balancing that goes on with the friction brakes, brake calipers and hydraulic units and like that. There's a bit of balancing that goes on from the trailer bogie. At very low speeds, the motor bogie friction brakes will come on. And then, as I said before, when the controller is put down into the red position in an emergency situation, all of the braking, all the different types of braking will be applied: electric, friction, and magnetic. So with sand being deposited on the rail, and which can be adverse in terms of wheel wear, and flange lubrication on the other hand, trying to minimize wheel wear. And you can have a sort of challenging factors which are making it very difficult to manage the wear of the wheels. So one thing in maintenance, we'll reprofile the wheels periodically, because if the profile is not to a standard at first, it can be a safety problem, or it can also lead to further deterioration of the track. You know, if the profiles aren't what they need to be, then you can end up having corrugation on the rails, which is a sort of a wavelength, and then that can then lead to increased wear and other problems. And again, the condition of the track, where you have, you know, we'll do regular measurements of the gauge, and we'll look for rail defects and such as squats, which all can have effect on your wheel wear. So when you're trying to optimize the wheel life, there's a lot of things that need to be considered. So the you know, the maintenance team that's performing the checks on the wheels, how the maintenance teams actually machine the wheels, and then the driving style from the operator. You know, if they're constantly applying the sanding or constantly applying the track brakes, and that can have an effect on your wheels. And then again, the strategy that's applied in your maintenance plan, you know, that can affect the wheel to rail interface. So that's hopefully that's sort of a general enough overview of some of the systems on the trams, which will then allow me to talk about what it is we do in maintenance. So in Dublin, there are 73 Citadis trams on 2 lines, on the red line and the green line. 66 of those are currently in service. So on the red line, there's 26 301 trams, which were they were originally on the green line, managed out of Sandyford, and they were extended to 401s quite some time ago, and 14 401 trams were originally purchased for the red line, and they're still there. So we have 40 trams available on the red line for use. On the green line, there's 26 402s, and very recently TII has purchased 7 new 502 trams, which the first one's actually here already in Dublin, and it should be going into service in the next couple of weeks, and the remainder of them will be delivered in the next couple of months. The first order for a Citadis tram ever in the world was here in Dublin, actually. So this was sort of the pilot project, and so it's a significant thing for Dublin. It's a significant thing for Alstom, and as you know already, with the completion of the LCC, now the network's grown quite a bit. So there's 38 kilometers covering 54 stations on the network. So this slide, then I'm going to give a quick timeline of the events on the Luas. So in 1998, the government got funding to start this project that they have now, and then by 2000, construction started on the first Luas line, and then in 2004, 4 years later, the green line was finished, and then the red line was finished. And to go with those, actually, if I back one up there, so to go with those, like I said before, there was 26 401 trams that were used on the green line, and 14 401 trams that were used on the red line. Then in 2008, the 301 trams were extended to 401s, and 26 new 402 trams were purchased for the green line. Those existing 401 trams were then moved over to the red line. Then over the course of the next 3 years, there was a number of extensions that were done to get the network to reach new areas. So the red line was extended by 1.5 kilometers to go to the point, where previously it only went to Connolly. Then On the Green Line, there was an extension of 11 kilometres to Brides Glen, and similarly on the Red Line, there was an extension out to Saggart. So that covers past events very generally for the Luas. Then most recently, we have the opening of the Green Line extension out to Broome Bridge, which now joins the Red and the Green Lines. And then future events. So by March 2018, the 7 new 502 trams should all be delivered, and then, but they may not make it into operation straight away. There'll be a process of commissioning them and testing them. And the Sandyford Depot extension will be completed now. That doesn't make any sense, but what that means is 502 trams are roughly 50-55 meters in length. The Sandyford Depot was originally built to accommodate a 40-45 meter tram. So the 502 trams are too long for the depot. So they've been undergoing an extension to both the north and the south ends of that depot to accommodate the 502 trams. And if you look at that slide, you're thinking, wait a second here, those trams are going to be arriving in March, but the extension's not even going to be finished in August. And yes, that's true, that's a fact. So it's actually causing us incredible disruption at this point in time, because the space that we need to do some of the maintenance is now being occupied by people who are carrying out construction works on the depot. So it's been very challenging the past couple of months to try to perform maintenance and have a construction site on the depot. Hopefully by August, when it's all done, we can get back to a slightly easier life on the Luas. So then by at the end of 2019, there will be the end of our contract. So currently Alstom has a contract for the maintenance of the vehicles and maintenance of the infrastructure. And separately, well, I'll come into this in the next slide, but separately there's a contract for the operation. So our contract will end in 2019, and there'll be a process of tendering to see if we can continue on post 2019 on the Luas. And that contract will be a sort of an operator-maintainer combined contract. By October 2020, the 402 extension to the 502 trams should be completed. So a project overview. So currently, as it's set up, you have TII, who's the asset owner of the vehicles. They own the rolling stock, the infrastructure, and the depots. There was an original supply agreement set up with Alstom to supply the trains, and there's evolutions to that agreement over the years, as you can imagine, with new 502 trams and like this. But they also had contracts to build the infrastructure, which were completely independent to Alstom. So that's been led by TII, and they project managed all that. And then there was the maintenance contract for the trams and maintenance contract for the infrastructure, and the operations contract post 2019. One key point. So the maintenance contracts aren't actually managed by TII anymore. They were novated to the operator to manage. So our main interface is to Transdev at this point in time. Post 2019, supply agreements will still be in place, but there'll be a single operator-maintainer contract for the Luas. So, to give you a bit of an overview of the vehicle maintenance contract, we carry out the tram maintenance in accordance with the maintenance plan. We also carry out cleaning of the vehicles. The overhauls of the vehicles are included in our scope as well. But in order to do that work, there's a lot of depot equipment like wheel lathes, cranes, lifting jacks, and hydraulic units. There's quite a lot of equipment that is needed to maintain the vehicles. So we also perform maintenance on that. That's in our scope. On occasion, we get asked to come out to incidents. So if there was a very large road traffic accident, we might be asked to come out, or if Transdev, the operator, is having difficulty recovering a tram back to the depot, then we would go out there and support them with that. A couple of key things in terms of our contract: the repairs to crashed trams and vandalism is in addition to our scope. So it's quite a disruption, but fortunately, the way it's currently set up, we're able to recover our costs from that disruption. The utilities such as phones, electricity, and water, and like that, that's all in the scope of the operator. So Transdev, they cover security as well, and TII own the rolling stock and the depot, and like that. In terms of the performance, we get measured with regards to how we perform in availability. So every day we're meant to offer 36 trams on the red line, and 20, I think it's, geez, I forget now, 23 on the green line. So if we don't meet those targets, then we'll get penalized. There's a bonus and penalty scheme in place. And similarly, then if trams drop out of service or there's a delay, because a passenger is struggling with the doors or something, then there's a reliability performance metric. Environmental equipment reliability is all to do with if there's any events in service where the tram doesn't need to come back to the depot for repair. However, there's a disruption to the passengers, we can get penalized for that. So if, what would be an example, if a lateral display is not working so you can't see what the next stop is, then we would get an environmental penalty. There's cleaning audits that are done to ensure that the trams are in a good state, and so there's a performance metric around that. For the infrastructure contract, Alstom, there's a consortium partnership between Alstom and Veolia to cover the work that needs to be done. Alstom's scope, we do inspections on the track, the OCS. There's a number of substations. There's signaling systems, telecommunications. The tram is equipped with an automatic vehicle location system. So in the ground, there's various loops that will allow centrally the control room to see where the trams are. So there's a communication there. The track cleaning, and then more recently, because of the age of infrastructure, we've started doing a lot of heavy civil repairs and track replacements. Veolia's scope, on the other hand, is more utility maintenance. They'll do cleaning and maintenance of the platforms and stops. They clean the park and rides. They also cover the landscaping, and they do inspections of various structures. So, the depot building itself, bridges, a few things like that. In terms of the performance on the infrastructure, this is a very challenging contract the way it's currently set up. There's 14 different performance criteria which are used to give out either bonuses or penalties. There's a category for critical systems. So any failure that results in a tram not being able, that's infrastructure related, that results in a tram not being able to be operated, will incur penalties for that. Now financially, those are weighted very significantly. And it can be quite challenging to try to address those problems that would then improve the Luas. For example, if there's debris in a points mechanism, then the tram can't pass over that set of points, and so there'll be maybe a 3-minute delay while the driver comes out of his vehicle and clears that debris and then gets back in and takes off. So that, if we were to get a very small number of those in the period, we would then incur quite a significant financial fine. And then if there's a more significant event, like of the order of 2 hours or more, then again there's an even increased penalty that would be applied for that one aspect of the performance criteria. We also get evaluated on our completion of the tasks required by the maintenance plan and how we manage rail defects. There's audits done every Friday with the customer to inspect the cleanliness and the condition of the infrastructure, and so all these things kind of pool in together to create a very tough performance regime. But at the end of the day, the customers deserve a very high standard, so it's probably quite a good thing actually that's there to help us try to improve the quality of the Luas. So for the depots, we have 3 depots now with the opening of the LCC, Luas Cross City. On the red line, there's only 1 depot, Red Cow. And then on the green line, you've got Sandyford Depot and Broombridge Depot now. with Broombridge being the newest, obviously. So each depot has various roads that allow us to do the maintenance. So you've got gantry roads, lifting roads, wheel turning roads, areas for doing overhauls of equipment and like that. There's also, each depot has its own tram wash and sanding shed. And there you got some photos. So the key thing about Broombridge, though, that's a very strange depot. It doesn't have a wheel lathe, and it's a very, very long and narrow depot. So what we can do there in terms of maintenance is quite varied from the point of view of Redcow or Sandyford. So as the depot is very new, we're currently having lots of discussions about what we might do there in the future to try to optimize the maintenance, and it's been quite interesting. So just to give you a bit of an idea of what those different types of roads are. So this photo here is showing you an example of gantry road. And our gantry roads are both, gantry and pit roads. So you can see on the left, you've got the tram will come in, and then the maintainers are able to get up on top of the vehicle and do maintenance of the equipment up there. And then beneath the tram, on the photo on the right, you can see the pit. So in the pit, we try to optimize the materials that are available to the guys that are performing the work, and we try to optimize their toolkits and like that. Now, there's a couple of technicians sitting here, so one thing to say about that is there's always room for improvement, continuous improvement. So, then in terms of lifting roads, so lifting road allows you to lift the tram up in the air, as you might gather from the picture, and then drop off the bogies so that you can move them to an overhaul or a workshop area to carry out further maintenance or overhaul. The wheel turning roads, you have, there's a wheel lathe that's below the floor. So the tram, if you can see, it's mostly marked up in blue, actually. The photo's not very good. But the tram will come over the blue area and allows a technician to machine the wheels on the tram. And then this photo here is showing you the workshop area that we have set up for the bogies. So on the left, that's they'll strip apart those wheel sets, change the wheels, they'll pull off the traction motors and do that sort of work. And the photo on the right is showing you the low floor bogie where they'll basically disassemble any component on that and then either overhaul it in another area of that workshop or it'll be sent away to have some other work done to it. In terms of the maintenance that we carry out, from the maintenance plan, there is a pre-service check that's done every day. That consists of, there's a lot of safety checks that have to be done. So every day someone will need to check that the brakes are working, the headlights are working, the wipers are working, they'll need to check that the tram can go into traction. There's audible warnings and things that they need to check. There's an announcement system for the passengers. So all these things need to be checked every day. It's just pre-departure check that's necessary from a safety point of view. Also, the sanding system and the flange lubrication system has to have the sand and the oil topped up. Windscreen wash, stuff like that has to be filled up every day. So those are all sorts of things that happen on a daily basis. Then you get into exams. With the shortest, or rather I should say the most frequent exam is every 15,000 kilometers, which equates to roughly 3-month period based on the current mileage of the trams. And then those exams start to pile up on each other with larger and larger scope. This little graph here shows you sort of the pattern of those exams. So you can see the 15K exam is relatively light. That includes a lot of inspections of the bogie, just to make sure things are securely attached and there's nothing hanging off the vehicle or could lead to an unsafe condition. There's a few minor tests that are performed on the roof where we check the carbon strips on the pantograph to make sure there's no damage that might cause problems with the overhead catenary, as well as there's filters in the air cons and heat vents units, so we'll have to check them quite regularly. And then when you get to a 30K exam, it's a repeat of all the activities that are done on 15, plus there's a couple of additional tasks now that are added in, and then the same idea for the 60. So that includes everything you do on the 30K exam, plus some extra tasks, and so on, and it builds up. So if you look at that graph, you think, well, there's a big increase in the amount of work between a 30K exam and a 60K exam. So on 60K exam, which is roughly once a year, we'll have to check the doors on the vehicles. And that actually is there's quite a lot of work in that. So there's a big increase in the amount of labor required. When you get to the 120K exams, then you start involving work that's needed on the braking system. So components will come off, they'll go into a workshop area where motors are changed and tests are performed. And then when equipment is refitted, there's a depollution unit that cleans the whole circuit to make sure it's working properly. In terms of overhauls, we carry out overhauls to these frequencies that you see here. So the earliest is every 300,000 kilometers. What's driving that figure is the life of the wheels. So because we get the wear and then we have to do the machining on the wheels, typically there's no more material left on them to be able to continue using them any further. So that's roughly around the 300,000 kilometer mark where the bogies have to come off, the wheels come off, they get disassembled, the tire piece is thrown away and a new one goes in with new rubber elastomers. There's a number of other smaller checks that are done at the 300K. But then when you get to the 600K, you have to do a repeat of all the work that's carried on 300K overhaul. But you start getting into a lot of other things. So in terms of the bogies, the brake calipers will come off. They'll go away to a supplier within Alstom in Spain, and they'll strip them apart, reassemble them completely, and perform tests. So the brakes get done. The traction motors will come off, and they'll go to the UK where they overhaul them. It consists of changing the bearings, making sure the windings are good on the traction motor. Then they'll reassemble and test the motors. The smaller items like various fans. There's a fan that circulates the air for the heat and vent and the air conditioning units. They'll either get changed or there's an overhaul that's required on them. And then when you get to the 900K overhaul, then you start including a couple of new activities, which are work on the doors. So the seals are made out of rubber, so after 15 years, you can imagine that they're starting to crack and deteriorate, so they have to be changed. So as part of the 900K, which we're actually currently in the process of doing on all of the 401 trams on the red line, we're overhauling the door mechanisms at the top where the motors get changed, the little brake mechanisms get changed, all the limit switches are changed out, and then the rubber seals come off the doors. So hopefully the doors will work a lot better after the overhaul. Additionally, on the 900, as you know, the trams, when they come around corners, they're articulating in between the cars. So there's a bearing in the articulation that has to be replaced. So as part of the 900K overhaul, every car needs to be split, and then so that bearing can then be changed. And that's quite it's quite onerous because you have to separate the bellows, split the trams very carefully, because you can imagine that's could be quite risky from an occupational health point of view. The cabling on the roof has to be all disconnected so that you can do that. So it's very labor-intensive overhaul. So it's the heaviest that we've done so far. The 1.2 million overhaul is 20 years, so we haven't got there yet. It's not in the scope of our contract. That'll happen post 2019. So I mentioned before that we're responsible for crash and vandalism repairs. Most of the time, the repair that's required is very light. It's just a simple scratch on a panel or a scratched or a broken window or something. So those are very easy to turn over. But on occasion, though, we get a very big road traffic accident like you see in the photo. So here in this instant, people may be familiar with this already, but near the museum area, that blue truck that's on the left jumped through the intersection and the tram collided with it. So you can see here that the tram derailed and the entire cab is a complete write-off. We spent quite a long time repairing this vehicle, and there was a lot of work. So we'll do an assessment of this damage, decide if we need any specialists to come in to provide extra support, and then we'll put in a plan and scope of works to try to bring this tram back. So that tram has been back in service for quite a while. But it seems that as soon as you've cleared that one, there's always the next tram that comes in to fill its place with a significant amount of damage. But so fingers crossed, there's nothing for the near future. So if anybody is driving a car and you think you might be a bit reckless, just take the tram. Just take the tram. So also part of our scope is we will investigate safety and quality issues. So on occasion there might be a safety-related incident whereby a piece of equipment is actually detached from a vehicle or something. So if that was to happen, then we would immediately communicate that amongst each other within the business, and we would start an 8D. An 8D, I believe, is actually a problem-solving methodology tool that was probably originated from Ford Motor Company. I'm not terribly sure, actually, but Alstom has sort of adapted that and put their own variation on it as a means of investigating quality and safety issues. So the idea is then, as soon as you know about an incident, you define the problem and share the information with various people within the business. You decide who needs to be in the team. So you might need to get some extra specialists that know something particular about what you're dealing with. Then, as part of the third step, you'll characterize the severity of the problem. So we'll always do a risk assessment, and the process applied by Alstom is actually quite good. So it's not something we've come up with here in Dublin. We have a corporate-wide way of categorizing the risk, and it takes in return of experience from various other sites worldwide, not just for Citadis, but also mainline railway. Then, as part of that risk assessment, you decide what mitigation actions you need to put in place to prevent the problem from reoccurring in the near future. So that's the fourth step. And then the fifth step, you have some actions to identify the root cause, and you don't close it until you've basically determined what the root cause is. So then once you know the root cause, then you can come up with permanent actions to prevent the problem from occurring in the future. And once those are implemented, you get onto the return of experience phase. So essentially within Alstom, there's people that are looking through these safety incidents and quality incidents, and they're deciding what changes need to be made to future railway products so that these problems don't come up in future. The last step then is just to recognize the people that are involved in the investigation. So really you just crack open your bottle of champagne and celebrate that you don't have to worry about that problem anymore. Our database, so we have we call it PST. It's a tool within Alstom. It stands for a problem-solving tool. So every 8D we raise, we stick into this database, and essentially there's people that go through that to sort of trend the defects and get return of experience. Now, it's actually quite a good thing to raise quality issues and safety issues, because it's all about continuous improvement. So across the world, our database probably has more than 80,000 either quality or safety events that we've decided it warranted this level of investigation. As well as Alstom was the original designer and maintainer of the vehicles, we're considered the technical experts sort of in terms of what we can do with these trams. But as the TII is not actually, as TII is the asset owner, they have put the responsibility onto Transdev to manage the safety case for these trams. So now if we were to make any changes to the vehicle, even though we were the original designers, we still communicate with Transdev, who then in turn communicate with TII about any change we want to do, and we go through a sort of a safety evaluation of what it is we want to do. But so it works well. There's lots of people looking at the things we want to do. So as Alstom, though, being the original designer of the vehicles, we have introduced various things over the years, which, for example, Train Tracer, which is a system that allows us to get information from the vehicles in terms of various signals from speed sensors or temperature sensors. It also gives us fault information from the tram management system, and then it sends that data wirelessly to a server, which then in the background will do some data analysis and processing, so that the guys in the front office can then make better decisions on the information that they see. You get from Train Tracer, you get positional information about the trams, as well as various variables and events. The system in place allows you to have email notifications when certain types of events or faults occur. You can see geographic location, and allows you, there's various tools within it to do data analysis and like that. Prior to having Train Tracer, we used to manually go and get the information from the vehicle. So a technician with a laptop would go and he'd plug in and he'd get the data out, and then that would have to be transferred onto another computer so an engineer could review the information. If you can imagine doing it that way, it meant it would probably be a day later before the engineer actually got the information he needed to review. But now if there was an event in service, we'll actually get a text message or an email to say, oh, there's this type of fault, and the engineer can go in and have a look, and he's sort of ahead of the game in terms of what he can do. Also, some other modifications that we fitted the trams. On the 401s, we replaced the original analog CCTV system with a digital system, and now it's actually been very successful. And with the new 502 trams, that's coming as standard. And then potentially the 402s will be upgraded to the same system. So Train Tracer, as I mentioned before, is one of the tools that Alstom has to feed into what is Health Hub. So there's other systems that can carry out inspections of the track. It can carry out scans of the overhead catenary or scans of the vehicle. Not all these are actually set up in Dublin, but just Train Tracer, which links into this Health Hub system here. But the idea is then there's now a portal where every bit of information you can possibly have from the vehicles or the infrastructure can then feed into this and allow people to make better decisions based on the data.